In this section, this is from section 8.2, number 37. We're given complex numbers z1 and z2 in rectangular form, as you can see here. And we need to find their r1 and r2 and theta 1 and theta 2 to find their quotient. So we need to get them into trigonometric form in order to find r1 and r2 and their thetas. So to get that into trigonometric form, let's start with z1. So for z1, r1 would be square root of the horizontal component squared plus the b squared, which gives me 3 plus 1, which equals 4, which gives me 2. And theta, these are both positive, so that's in quadrant 1. So theta reference and theta will be equal. So that's tan inverse of y over, or b over a. So that's 1 over radical 3. That's on the unit circle. So that is equal to 30 degrees. Now let's look at our second vector. I'm going to put the I in front. And r2 is square root of a squared plus b squared. Remember, the I is not part of the b. So I get square root of 1 plus 3, which is square root of 4, which is 2 also. And theta 2, again, these are both positive, so it's in quadrant 1. So theta reference and theta will be equal. So I get theta equals tan inverse of b over a, which is 60 degrees. And then so I found r1, r2, theta 1, theta 2. And now I need to find the quotient. So let's do a different color for that. Let's do z1 divided by z2 equals the r1 let's see. So there's our formula for that. And the r1 is 2. And r2 is also 2. And theta 1 is 30 degrees. And theta 2 is 60 degrees. So I get 1 cis of negative 30 degrees. So that's in trigonometric form. But then it says to say, find the quotient in rectangular form. So that's a trigonometric form answer. But to find the answer in rectangular form, I can expand this to be cosine of negative 30 degrees plus I times sine of negative 30 degrees and the one I don't need to write the 1 because 1 times anything is the anything. Cosine of negative 30 is radical 3 over 2. And sine of negative 30 is negative 1/2. Plus I still have that I there, which I'll put after. So there's my final answer in rectangular form. So that's